alaikum wa rahmatullahi wa barakatuh. Hello everyone. In this video I'm going to explain the AOT exam questions starting from question 1 to 5 in this video and to be continued later with other videos for the rest of the questions. I will go like 5 by 5 questions every time. Okay, let's get started. This is the first multiple choice question 1. It's from module 5 lesson 1 graph exponential growth functions. Here we go. So in this type of questions he will ask you to graph the function f of x, for example, equal 3 to the power of x, as long as the learning objective here says like growth function. So always the base here, which is 3, like b equals 3, always will be greater than 1, so it's representing a growth function. This is the first thing you should know. So if I'm graphing a growth function, it must be a function looks like this, passing through what here, if you remember, it will be passing through 1 if the graph is not transformed. We will see in other examples when the graph is transformed later in other questions. However, for now, if there is no transformation taking place, so it will be passing through 1 whatever the base here, if it's greater than 1. Alright. However, in other questions when we will have a transformation, we will talk about this in other examples, inshallah. Type one more thing, it's important, as long as this will be a multiple choice question, so he may give you the function asking you to choose the correct graph. So I'm going to be choosing a graph passing through 1 looking like this. So for example, if I have another one, like another graph passing through 1 as well, but it represents a decay, it will be rejected. I can have a graph looking like this passing through -1, still will be rejected because there is no reflection taking place, like what we will explain in other examples. Alright, now let's remove this and start all over again. So now we know how the graph look like. It will be an exponential growth function passing through 1. So I will put a point here. I'm sure that the graph will be passing this point. Now if you remember, to graph a function, what we will need to do, if you remember, we need to use a calculator to create a table of values with a function of 3 to the power of x, and you can use values, if you remember, the start and end from -5 to +5. So what you will see is -1, 2, 3, 4, 5. You will find, if you will use a calculator, like values very small, like 0 point something. So I'm not using a calculator now, but you can use a calculator. You will find it's a very small values, so I will not touch the x-axis, but there will be points very close to the x-axis until you will come to a -1 here. It will be 0.333, so it's like third of the distance between 0 and 1. Then when you will check the table on the calculator from 0, it will be 0 and 1, then 1 and 3. Yeah, here we go. Then 2, and you will find it is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just I imagine that there is a point here, so I know that where is my direction now. Type. If I want to graph this issue, I will try to do my best. You know, I'm drawing in a tablet, so it will not be very accurate, but I will draw like a curve very close to x, but I will not touch it. So I'm trying hard to do my best here, crossing this point and go towards this point, but I will not go over. So I don't forget to put the arrows. So this means like the graph is extending from both sides. Of course, this is not a very accurate graph, but in the exam you will see like different graphs. You will choose this one similar to this, passing through 1 here, and you will find the point 1 and 3. This will be the most important accurate point that you have, and 2 and 9 if you have an extended graph. Alright, yeah, this is for graphing the exponential growth function. All what you need to do, create table of values, then graph it, but you should know earlier in advance how the graph look like, so you will be sure that you are choosing the right graph even without graphing it. The second part here is to find the domain and range. As you all know, either it's a growth or a decay. The domain is always the x values, which means I'm talking about the x values. This means x the values on x-axis like right and left. The graph is covering both right and left sides of the graph with extending ends, which means go all the way to the left and all the way to the right if it will extend to infinity. So right and left are covered. So the domain here is all real numbers. Sorry for the handwriting, guys, but I'm sure you understand what I'm saying. So all real numbers. Is there another way to write this domain? Yes, there is. I can write it as an interval from negative infinity to positive infinity. An open interval from negative infinity to positive infinity that covers all real numbers. What about the range? The range is representing the y values, which means I'm moving over the y-axis like up and down. So as you can see, the graph is only covering the top part or the upper part of the graph. It's not going anywhere down, which means all the y values in the negative section here is not covered by the graph. The graph is going all the way starting from 0 and going up. However, it's not going to touch the x-axis, and we know that this x-axis has an equation of y equals 0. This is very important to remember, Yashab. The x-axis has an equation of y equals 0. This means it will never become a y equals 0, but it will be any number after 0 and going towards positive infinity. So the graph is starting from 0 but will not be 0, going up to positive infinity. So the range here could be all positive real numbers. And we have other methods to write it: open interval, and an open interval from 0 to positive infinity, or we can write it using the set notation as f of x, such that f of x is greater than 0, any value greater than 0. Of course, this could be replaced by y, if remember y, such that y is greater than 0. This is for the domain and range. What about the y-intercept? As you can see, what is the y-intercept? The y-intercept is the point where the graph crosses the y-axis, so it's very obvious, it's a 1. Even without looking at the graph, we know that if it's not a non-transformed graph, it must be passing through 1, whatever the value of the base is, if it's either growth or decay. So the y-intercept here is 1. What if the choices are given in ordered pairs? So I must write it as an ordered pair. So this will be the y, where the x is 0. So this point is 0 and 1. Take care, Shab. Usually you will find answers like 1 and 0, which will be wrong. So keep this in mind. Y is 1, x is 0. This is the coordinates of the point. The asymptote is the line where the graph coming very close to but will never touch, and it's very obvious this line here is the x-axis or y equals 0. So we can have the x-axis as a choice or y equals 0. Both of these works for the asymptote, so both works. You can find any of them in the choices. For the end of behavior, as you can see, we see when the graph, like you are starting from the middle of the graph, going to the left side towards negative infinity, then go to the right side, which is positive infinity, and see what happened to f of x, which is the y. What happens to the y? So if I'm going to the left side, the y values, as you can see, the y values moving up and down is coming, as long as I'm moving to this direction, going very like decreasing in this direction until it reaches 0, so it's coming towards 0. We said it will never be a 0, but it's coming very close to 0, as you can see from the left side. However, from the other side, if I'm moving towards positive direction, like to positive infinity of x, what happened to the y? If I'm moving to the other direction, the graph is going towards, like going very all the way up until it hits it will never reach, but it will be a positive infinity, like it's extending on the right side all the way up to positive infinity. That's it for a question 1, Yashab. As you will see here, You will have a lot of examples like similar. The only thing will change are the values you will find on the table of values, but most of the answers are the same except if the graph will be transformed. So here is the first transformation that I have. For example, if there is a number multiplied outside, what this number will affect type. If you remember, if I have a number outside, the general form of the transformed graph is f of x equals a multiplied by b to the power of x minus h plus k. We will talk about h and k in other example. If you remember, they are in charge of the translation of the graph, right left with h, up and down with k, and a is in charge of two things. If a is negative, it will reflect the graph, right? So for example, if the graph should look like this, if reflection happens, it will go like this, like reflection over the x-axis. And there is something else, which is the dilation of the graph. Either the graph is compressed or stretched type. What will be affected here? So for example, imagine you grabbed 3 to the power of x. We know that the graph will pass through the 1, and it's exactly the same as the first one here. So if you will go back 3 power of x, and we have a point as 1 and 1 2 3 like this one, and here we have a third value like this one. So we can imagine the graph looks like this, right? This is the 3 to the power of x. What if I'm multiplying by 2? It means all of these values will be multiplied by 2. So the most important one for me is the y-intercept. If the y-intercept, we know it's always 1, when I multiply by 2, this y-intercept will no longer become a 1. So now it will be 2. Yes, it will be 2. What about the value of 1 and 3? This was the second point, the second accurate point that I know. It will no longer be 3. It will be 1 2 3 4 5 6, because it looks like you will multiply all the values. Imagine, Shab, you have the values from the table, from this one, all the values will be multiplied by 2, so it will be n6. So what will happen to the graph now? It will be something similar to this, right? But still, you can use the table of values to graph. I will remove the red one to see how the graph looks like now. So you still can use the table of values and graph it even if you don't know anything, but it will be very easy for you to choose the graph that looks like this, passing through to if it's a multiple choice when you see a 2 outside. Let's see if there anything will be affected here. Actually, nothing at all, as long as the graph is not translated, which means there is no h and no k. Nothing will change at all in all of these, which means the domain is still all real numbers. The range is still it will be f of x, such that f of x is greater than 0, because the graph is still above the above the x-axis, and it's starting from 0 to infinity. The y-intercept, the only thing will change. I know now it's no longer 1, it's a 2, so it will be 0 and 2 as a coordinates, or as a value it will be 2. The asymptote is still the x-axis, or y equals 0, the x-axis, or y equals 0. The end behavior, negative infinity, it will be 0. Positive infinity will be positive infinity. That's it. So the only thing that it changes here, ya shabab, is the y-intercept. And what will be the new y-intercept? It depends on the value that we have here. Alright? What if I have a question like this including a negative sign? If you remember, we still have, like, if ignore the negative 2 now. If it's a 4 power of x, it's still, this is the value of b equals 4, the base greater than 1. It means it represents growth, which means the graph should look like this, passing through 1. Now, I have a 2 outside, so instead of 1, it must be, I know that the graph must pass through the value 2. It's not a 1, it will be a 2, because there is a 2 multiplied outside. What if we have a negative? The new graph which passing through 2 will be reflected down. So instead of going 2 points up, I will go 2 points down, passing through negative 2. So we will look for a graph passing through the negative 2. Alright? طيب what if I want to graph this one like accurately, but we know how it looks like if it's a multiple choice. As we said earlier, we will create a table of values. You will find here this value. So let's say if you will use your calculators, and let me use my own calculator here. So we will go to the table of values, which could be mode 7 on some calculators, for others mode 9, mode A. You know how to find the graph. You will write -2 on the calculator multiplied by 4 to the power of x. Write it exactly يا شباب as you can see on in the question, with the bracket, with everything. Start from -5, end with 5, and create table of values. You will find I will start from -3, for example. It will be here -1, -2, -3. As you can see on your calculators, -0.03, which means a value very close to 0, like as close as possible. Then -2, -0.1, like 1 part out of 10, and then -1 and -0.5. -1, -0.5, it means exactly in the middle. Then you will find 0 and -2. 0 and -2, which I'm sure of this point. I know it earlier from the transformation or the reflection. 1 and -8. 1 and -1, -2, -3, 4, 5, 6, 7. It's somewhere here. And then you graph the function. So we will have like, I'm trying يا شباب, I'm using a tablet as I explained earlier, so I'm doing my best, but it should be like a bit up, like from here, like this. I hope this works. So let me see if I will remove. It will all be removed, like, yeah, okay. It will be something like this. خلاص يا شباب, you know how it looks like, but I'm drawing it on a tablet. So actually you will be choosing it from a multiple choice. You don't have to be drawing it if it's a multiple choice question. طيب, what about the domain? Actually again يا شباب, domain will never change, so it's all real numbers. Type. What about the range? Oh, the range will have a change here, because remember in the previous question it was covering the upper part of the x-axis, but here it's covering the bottom or the below part of the x-axis. All the graph is below x, which means we reflected it. So it will start from like the y values coming from -infinity from all the way down until the maximum here is, if you remember, this is the x-axis, y equals 0. This is the maximum y value we can get. So it will be from -infinity to 0. This is the range, or we can write it y such that y is less than 0, because now it's below 0, not above the 0. Or we can say all negative real numbers. Type. Which one I should expect in the exam? Actually, you could expect any form of these in the exam. You have to be aware of the 3 forms, because it could come in the exam in any of these forms. Type. What about the y-intercept? The y-intercept, we said where the graph crosses the the y-axis, which means here we have a value of -2, so it will be -2. As coordinates, we just add a 0 to it, so it's a 0 and -2. Again, as long as we don't have any h and k values, no translation taking place, like not moving right, left, up or down, the y-intercept, the asymptote is still the x-axis or y equals 0. What about the end behavior? Let's say the end behavior, as long as moving to the left side, the y value is coming close to y equals 0, it's coming to 0. When I'm moving to the right side, it's moving all the way down to, yes, to -infinity. Okay, shabab? Now, for the transformation graphs, I will explain it, but not here. In the next part, you will see later. So, for example, this is what the type of questions you may expect in the exam, the multiple choice. So f of x equals 4 to the power of x, select the graph. So first of all, I will look at the value of b here. As we know, b here equals 4. We said greater than 1. It means representing growth type. Growth, it means if you start from, we always start from the left side. Go with the graph. Is it increasing or decreasing? increasing, it means growth, so this could be an answer. This one starting from the left, it goes down, which means decreasing, so this choice is wrong. Starting from up, going all the way down, is it increasing or decreasing? As it's very obvious coming from the left, it's decreasing, so this is a wrong graph. Here starting and going up, this is still a growth, it could be an answer. But let's say this graph is a normal graph, no translation, no reflection. Is there a negative outside? No, which means this will be the correct graph, because this graph, it's very obvious, it's a reflected graph, which means I need to have a negative here, so this one will be wrong, so the choice will be letter A. One more thing, you can create table of value. If you are not sure enough, you will find 0 and 1, of course, so this will be the answer. A negative one here could be an answer if it's this one could be a graph of f of x equals negative 4 to the power of x, but not 4 to the power of x, because this graph is reflected. This is how you do things in the exam, so it could be very easy if it's a multiple choice. Now, question 2, it's module 5, lesson 3, analyze expressions and functions involving the natural base e. Before we start, ya shabab, do you remember what is e? Can someone remember what is e? E is a constant similar to, yes, exactly, similar to pi, which is 3.14. However, e has a different value, which is 2.718. For example, it's like a very long number, but with 3 decimal places, it's 2.718. All right. First of all, what I need to know about e, of course is greater than 1, so if I will use it as a base for a function f of x equals e to the power of x, it will represent growth. It will represent a growth because it's a greater than 1 value. All right. Now let's head to the question. Graph the function with base e. It's the same thing. However, this graph, as you noticed, is a transformed graph. It says consider g of x equals negative 2e to the power of x minus 3 plus 2. If you remember again, let me remind you, f of x equals a multiplied by b to the power of x minus h plus k. We have two methods. The first one is to solve, and the second one to choose the correct one. So let's go over the first one, which the harder, when you need to graph, it's not very hard, but let's say what h and k represents. If you remember, h is representing the translation by moving right and left with changing the sign. Don't forget, ya shabab, we change the sign. What does it mean? If it's, for example, b to the power of x minus 2, it means move 2 steps to the right. So minus 2 means to the right. If it's a plus 2, move 2 steps to the left. Remember that. And k will be in charge of moving up and down, and we will not change the sign. So if it's a plus 2, 2 steps up, minus 2, 2 steps down. So keep this in mind while we are solving, ya shabab. There is something very important as well. What is the center of the graph? For example, if it's f of x equals e to the power of x without translation at all, the graph has a center always as the origin, which is 0 and 0. Now, what happens when we have a value of h and k? The center will change to the new center, which will be h and k. This will be acting as the new center of the graph. New center means where the x and y intersect. So it looks like we will have a new simulation of x and y. So for example, if I'm graphing something, I should pass through 1. So I will graph an exponential function passing through 1. But if this graph is transformed, like I have a new center, for example 2 and 1, just an example, I will go to the point like 2 and 1. This will be the new center. I will simulate I have the this will be the new x-axis and this will be the new y-axis. Then I will go 1 step up and then graph it. Right? Let's see this in details with the example that we have here, ya shabab. Okay. Now I will go back to our question. Negative 2e power of x minus 3 plus 2 As you can see, this is the value of h and this is the value of k. So I need to decide what will be the new center. This should be the first thing you do. So the new center, don't forget x minus 3, change the sign, it will be 3. Here we have positive 2, we keep it the same. So this will be the new center, 3 and 2, and I will plot it on the graph. 1, 2, 3, 1, 2. Here is the new center with h and k. Okay, now imagine ya shabab, we have now the new, like these will be the new x and y axes. We are not moving the x and y, but we are simulating, like looks like we have a new center with a new graph here. And let's see. All right, so if I'm drawing a normal function and there is nothing multiplied outside, like this is the value of a, if you remember, I will just go one step up and then the graph should look like this. However, this is not the correct graph because we have a transformation taking place here. So if I have here a value of a equals negative 2, so I know now a equals negative 2, which means first of all the graph will be multiplied by 2, or the values will be multiplied by 2. So instead of 1 point up, it will be 2 points up. Now we have a negative. This means this graph is reflected. This graph is reflected. So if the graph is reflected, instead of going 2 steps up, I will go 2 steps down, and this will be the point, and the graph should look like this. Okay, Shab, this is how the graph should look like. So if it's a multiple choice, I will choose a value where the graph looks like this. However, to be more accurate, we will create a table of values using your calculators as usual. So let me write this down and see how the table will look like. So it's a negative 2 multiplied by e to the power of x minus 3, and we have plus 2, and the start is negative 5 as usual, and 5, and let's see how the values look like. So you will find like negative 5, negative 3, negative 2, or even negative 1. All the values are, as you can see, it's negative, let me just move up, ya shabab, a bit. Starting from, sorry shabab, I had a problem with the calculator, sorry. Now I can see it. Negative 5, negative 4, negative 3, negative 2, negative 1, and even 0, all of them are 1.9 something, right? Which means starting from negative 5, 1, 2, 3, 4, 5, it's a 1.999, so it's a value very close to 2 until 0, like just I have some values very close to 0. Then 1 starting to drop a bit, 1.7 or something. 1.2 with a 2, with a 2, 1.2, so it looks like this. Then we have 3 and 0. Now this will this will point, especially will let you know that your work is correct, because I knew it earlier. Then 4 and negative 3.4, 4 and negative 3, 1, 2, 3.4, like directly before the half, and then it will be negative 12, so I will not take this point. Now all what you need to do is to graph this. I will try like hard to do my best here. Okay, so I will go down, passing through this point all the way down, and put the arrows in both sides. That's it. Type. If it's a multiple choice, all what I need to do, ya shabab, is where you can use a draft paper to draw this and simulate, it's a negative 2 here, and I know where is the intersection. You will look for the graph having this shape. Actually, ya shabab, in the final exam, if it's a multiple choice and I don't have to graph it, but I can draw a draft graph like what I have done earlier at the beginning, choose the new center, highlight it. You can create on a draft paper. I can even do like something similar to this. I know it's a 1, 2, 3 and 2, like here is the point, here is negative 3. Simulate something like this, and negative 2. We have like these are the 2 new axes, for example. And instead of going 1 step up, I have here 2, so I will go 2 steps up, but it's a negative, so I will go 2 steps down, which means I will go back to this point. This is an asymptote, so the values should go like this. I will choose a graph similar to this, ya shabab. This is how I do it if it's a multiple choice. Now, okay, this is the first part, graphing it. So we graph the transformation and using E at the same time. Now let's solve the part B, determine the domain and range. So let's see the domain and range, and let's see if there is any change. Actually, we said the domain will never change, still from left and right, covering all the left and right parts of the graph. So this means it's all real numbers. But the range will change in this case, because as you can see, the graph is moved 2 steps up, which means this line now is no longer y equals 0. This is the line y equals 2, which means I will take all the values of y from down and I will stop at 2. So it will be starting from negative infinity, because it's moving all the way down like to negative infinity, but it will stop here at 2. This is the maximum y value I can get, and it will not be used, the value of 2, because that's an asymptote. So I will keep it an open interval. That's how we write it. Type, how can I write this as a set of values? It will be y such that y less than 2, because it's starting from 2 and moving down, you less than 2. This is for part B. Part C, find the average rate of a change. For the average rate of a change, if you remember, this is the rule of the average rate of a change. We find it f of b minus f of a over b minus a. But remember, Shwab, the interval that he will give me in the question is always a and b, where a is the start value and b is the end value. So the rule always start, if you remember, end minus start. So we can say it's always the end minus the start to see the difference in the function over the difference of the values. This is how we calculate the average rate of a change. Which means to solve this, I will write on the top here a, and here I will write b. So what I need to calculate now to be able to solve this, I know the values of a and b now. I still need to find the values of f of b and f of a. So what I will do, I will find f of a, which means I will replace a with the value -4, which means f of -4. What does it mean by f of -4? It means like I will go to the original function, I will replace x by -4. Sorry, here we have a g of x. It doesn't make any difference, but just to know this is the correct letter to use, but there is no change in the method. So it will be g of a, g of -4. It means I will go to the function g of x and I will replace x by -4. Let me just remove this so you can see the function a bit. So all what I need to do, I will rewrite the function again, but I will replace x here by -4. So I will write here -2 e to the power of -4 minus 3 and plus 2, and find the result with the calculator. Then I will find g of b, which is g of b equals -1. So I will go to the original function, but I will replace x, instead of -4 I will use -1. So it will be -2 e power of -1 minus 3, and we have here plus 2 equals. Let me use a calculator. I cannot calculate this without a calculator, even myself. So we will write that -2 e to the power of -4, -3, it's a -7. You don't have to solve it, you can just write it -4, -3, and we have plus 2, but be sure you write it correctly. I will take the answer, like let's say to 4 decimal places, so it will be 1.998, or 3 decimal places is enough. Now I will go back and I will change only the value of the exponent. Instead of -4, -3, -1, -3 is -4, and I will find the answer. So it will be 1.963. Okay, yes, that's enough. So and we have a and b. Now I need to apply the rule. So the average rate of a change will be f of b, or sorry, here in our question will be g of b minus g of a over b minus a. So I will just substitute, ya shabab. G of B, we calculated it, 1.963 minus G of A, 1.998 over B minus A. B here is -1 minus -4. So we can write this on the calculator and see what is the result. So I will write it down, 1.963 minus 1.998 over 1 minus -4, it means a +4. Sorry, it's a -1. Yep, -1 plus 4. So the answer will be approximately equals, because it's a very long number, -0.0117, just a rounded value. Okay shabab, so this is how we calculate the average rate of a change, and of course it will be a multiple choice, so you can look for the choice that is corresponds to your answer or similar to your answer. Okay shabab, all the questions here are the same. Now let's go to question 3. It's module 6, lesson 1. Write logarithmic expressions in exponential form and write exponential expressions in logarithmic form. So it's like converting between logarithmic expressions and exponential expressions type. Let me just remind you very quickly. So let's go back here and I will remind you with how can we convert between them. So let's say if I have a to the power of x equals b, for example, what we call this, exponential or a logarithmic form? Yes, it's an exponential form as long as I cannot see a log written here. To change this to a logarithmic form, we know that, but let me write this in a form that will be easier for you to remember because of the base. So I will write it as b over power of x equals a. We used to have b as a base, so it doesn't make a difference, but just to remember it easier way. So b to the power of x equals a. When we write log, we have a number we put here which is always the base, which means this must be b here. And this is the answer of the question. I will place it here, equals x, which is the exponent. So remember, in the logarithmic form, what is written here is always the base. What is written as an answer of the logarithm is always the exponent. This is how to remember it easily. We write it that way. This is how to convert from a exponential to logarithmic form. How can I do the other way around? If you remember, it's still easy. We write the base, which is b, to the power of the exponent, which is x, and the answer is here. And if you remember, I have told you a way. If you remember this, b to the power of x equals a. I used to do it even myself that way. B to the power of x equals a. B to the power of x equals a. Now, let's try this here. Here is a logarithmic form. He said write each equation in exponential form. What I will do, this is the logarithmic. Remember, I have 15 to the power of 2 equals 225. So 15 to the power of 2 equals 225. You can find in the answer 225 equals 15 to the power of 2, still the same thing, so just keep this in mind. Alright, now let's have another one including a fraction or something like this one. Again, here is the base, so 3 power of -3 equals whatever is written here. So 3 power of -3 equals 1 over 27. As simple as that. For let's have a harder question here. Anyway, all are the same. 4 to the power of 5 over 2 equals 32. You have 4 to the power of 5 over 2 equals 32. This is the first type of questions. The other one is the inverse. So what I will do, I will just write log. What is the base here? Very obvious, the base here is 2, so I will place it here. Go to the answer, I will write it in the logarithm, so 128 equals the exponent, which is 7, so it's equal to 7. Right. What if I have something including a fraction or both fractions like this? Same thing, it's a log. What is the base here? All the fraction here is the base, 1 over 7. What is the answer? 1 over 343 equals the exponent, which is 3. As simple as that, ya shabab. Now, question 4, module 6, lesson 3, evaluate logarithmic expressions by using the change base formula. Type. the change base formula, as you remember, if I have, for example, log a to the base b, I can rewrite it as log a over log b. So I can split it into two logarithms, log a over log b. The question here is, I doubt if someone doesn't remember, what is the base? I'm not showing any base here. Actually, you can try this with several examples. If I don't show the base, this is the most important thing. We have something called common logarithm. What is the common logarithm? If I'm writing log a without a base, this means log a to the base 10. So if there is no logarithm shown, this means this base is 10. Alright, so this is a common thing. That's why they call it a common logarithm. If there is no logarithm base of the logarithm shown, this means a log to the base 10, and this called a common logarithm. Type. What if I change this to any other value? Will this change the rule? No. For example, if I put here 5 and 5, it will be the same. If I will put 7 and 7, it will be the same, but it must be exactly the same base for both. Now, let's solve the question. Evaluate log 11 base 2 by writing in terms of common logarithm. Common logarithm means I will use log only, which means of a base 10, but I will not show it. Type how I will do this. Log 11 to the base 2, it means log 11 over log 2, and find the result with the calculator to the nearest 10,000s. 10,000s here means write 10,000. It means how many zeros do you have? 4 zeros. It means 4 decimal places. So you can write the answer with the calculator and find the result. Actually, I doubt they will ask you to round, because otherwise I can just put this on the calculator and find the result to 4 decimal places. Or if you will use the other one here, you still can use a calculator, but you will find it the same result. So for example, it's log 11 to the base 2, it will be approximately to 4 decimal places 3.4594. okay shabab, log 11 to the base 2. But what if I didn't find this in the question, in the choices? Maybe you can see either this in the choices or this form in the choices. But maybe I can find something else like log 11 log 2, and he put here base 5. Is it a correct answer? Yes, it's still correct. He doesn't have to ask you to use the common logarithm, but he will say change the base formula to solve a log 11 to the base 2, and he will not show you the answer as decimal. He wants you to show it like this. Now, what could be the choices? It could be, for example, for the common mistakes, log 2 over log 11. Is this correct? Of course, I must start with the log 11, then base 2. The base is always in the denominator, so this is wrong. He could give you log 2 to the base 7 over log 11 to the base 5, or sorry, log, I will put them in a correct order, but I will change the base. Log 11, log 2, but he changes the base, which means this is wrong. I can only use exactly the same base, or not showing the base, which is the common logarithm base of 10. That's it. All what you need to do is to split it, like for example any question like this one here. What I will do, log 200 over log 12. That's it. If he wants the final result, or if you can see this and you see decimals, put it on the calculator and find the result. Now question 5, module 6, lesson 4, simplify expressions with the natural logarithm. Type, what is the natural logarithm? First of all, the natural logarithm that uses the natural base. The natural base. What is the natural base? The natural base e, which means I will have log to the base e, and we used to write log to the base e as len. So if it's a log x to the base e, it will be directly len x. So this means the log to the natural base e. Alright? Now, write as a single logarithm. To be honest, before you start this, you must remember some of the properties of adding and subtracting an exponent of the logarithms. I will go over it very quickly. If I have, for example, log a plus log b, what will be the result here? If I have a plus and I'm adding two logarithms, it will be log, and instead of writing log a and log b, I can write them as a single logarithm and use a multiplication. It will be ab. But what if I have the same question, log a but minus log b? What will happen here? It will be log, as long as this is a minus, I will divide a over b. A is the positive one, it will be up, minus log b, it will be down. So I will put log a over b. This is the division rule. We have the exponent rule as well. If it's log a to the power of b, for example, if you remember, I can take this exponent and put it outside, it will be b log a. And this works both directions. Like if I have a b outside, I can put it back as an exponent and write it up here. And this is the most one I will be using to put this back. Why is that? Because to be able to use both of these properties, add and subtract, you must solve where no factors are outside in both of the or more. Like I can't have anything outside to be able to apply this rule. So if you have any factor multiplied outside, put it back first, simplify, then go and apply this rule. So I will do this first, then apply any of these rules. Now let's go directly to the question here. I will look at the question, write as a single logarithm. It means I want to combine them all. Now the question is, can I start doing this directly? No, I can't, because I have a factor multiplied here which is 1 over 3. So the first step is put it back as an exponent of 8. So I will rewrite this as len 8 power of 1 over 3 minus len 3 plus len 9. Alright? Type 8 power of 1 over 3, you can use a calculator directly, or you should understand this is a cubic root of 8, which means 2. So it will be len 2 minus len 3 plus len 9. Now and only now I can use a single logarithm like len, and I will make a fraction because I have more than a sign, plus and minus, so there will be numbers up and numbers down. 2 here is a positive, like it's a positive number, so I will put it up. Minus 3, it means I will be dividing by 3. Positive 9, it will be up, which means I will multiply by 9. So as long as 2 and 9 are positives or added, it will be multiplied. Subtract len 3, it means 3 will go down and divided. Then when you put this on the calculator, don't put the len. I need to simplify this only. I need to simplify the fraction, not the len. So I will leave the len, put this on the calculator, you will come up with 6, and this will be the final result. Alright? Let's have another one. Like, is there any other difficult question? Let's have one with like fractions, and let's say how it works. Like this one, for example. First of all, we have a factor outside and we have another factor outside. I will put this factor back here and there. So what will happen here? It will be len 1 over 3, but here, as long as this is a fraction, I must put a bracket to the power of 4. If I will put this 4 up, it will be a power for the whole fraction 1 over 3 minus len 1 over 9, the same thing, all to the power of 6. Now I don't have to simplify it, now I can leave it. So I will write here len, make a fraction, because there are two terms and there is a minus, which means divided. It will be 1 over 3 all to the power of 4 over 1 over 9 all to the power of 6. 1 over 9 all to the power of 6. When I simplify, ya shabab, don't forget we only put this on the calculator to simplify. We simplify the fraction, not the len. So that the answer will be len, and let me do this either with you on the calculator. So we will write it as it is. We will open a bracket, put a fraction 1 over 3 all to the power, close the bracket and make it all to the power of 4, and divide by, open a bracket, make a fraction 1 over 9, close the bracket, create a power, and this is a power of 6, and find the result. You will see the result is 6561, 6561. This how you calculate this, ya shabab. I don't think we have any other difficult questions, all look similar. So these are the questions 1 to 5 from the multiple choice, and as I mentioned, ya shabab, it will be continued with the rest of questions. I will record videos like every 5 questions I will be recording a separated video, so it will be easy for you to either for me to upload and for you to follow. Thank you so much for watching this. Study hard and be ready for the final exam.